Good morning, everyone, and welcome you all for today's lecture. Today, we are going to discuss about solar angle geometry because this topic is very interesting to understand how solar collectors works, and because whenever we have to install solar collectors for harnessing of the solar energy or any collector, whether it is a flat plate solar collector, concentrating collector, or parabolite collector, to harness solar energy, we have to check the angle. What angle incident radiation coming on the surface of the collector? This is very important, and so many angles are involved, and that angles we are going to discuss today. So first, the most important angles are longitude and latitude. And longitude and latitude is very important from general knowledge point of view, because we know that Earth is inclined at a particular axis, a 23.45 degree inclined to from its central axis, and with this inclination it revolves about its own axis anti-clockwise and also revolve around the sun. So seasons varies due to inclination of Earth about its own axis. So all these things are very important to point out what is location of any city or any place, and also we have to apply Google Map by using these longitude and latitude. So we have to discuss today. We will also discuss longitude and latitude, and these angle also involve in solar angle geometry, because whenever we have to calculate incident radiation on the surface of the collector, we have to measure the angle of inclination of the collector and incident angle with the normal to the surface of the collector. That is this angle is very important, because we have to resolve incident normal beam radiation on the surface of the collector. So that's why this angle is very important, and this angle varies as Earth rotates around the sun. That's why continuous tracking of this angle is important. So first we discuss what is the concept of longitude and latitude, because it is also important from geographical point of view, from geography, how we locate particular position. If we know longitude and latitude, this is very important. So let us see what is longitude and latitude. Longitude and latitude, and this is sometime it is also confusing which is known as longitude and which one is latitude. That's why we are going to discuss to define longitude and latitude. So first, take a circle. Earth rotate about this axis, and this is the angle of inclination. This is angle of inclination about 23.45 degree constant angle, and we can divide this Earth's surface, whole of the Earth, in terms of latitude and longitude. Longitude means about vertical axis, circle without about vertical axis, and latitudes circle perpendicular to vertical axis. So first we define longitude and latitude. First we define latitude. Suppose this one is this point. This is a equator circle. This divides the Earth about 50-50% north globe and south of north and south. So this from here we take reference, and this reference uh, take 15 degree, 30 degree, 45 degree, 50 degree, 75 degree, and this one here 90 degree, because each circle, because 1 hour equal to 15 degree, so whole of the globe can be divided into 360 degree, means 24 circles, 12 here and 12 opposite side. So these circles are known as this circle, because you can say cut slices of circular disc, and whole of the Earth can be cut, because each 15 degree means 1 hour. 1 hour equal to 15 degree. Similarly, we can draw here longitude. This is a longitude. These are longitude. The yellow color lines are longitude. Now these are, here we have started from here 15 degree, 30 degree, 45 degree, 50 degree, 75 degree, 90 degree. So these are longitude, and so these vertical lines, you can see yellow lines are longitude, and the green blue lines are latitude. So any location you can define with the help of longitude and like any location. Suppose I want to define Delhi location. I'm not considering arbitrary, and angle is given 24 degree and 75 degree. So 24 degree first digit is known as latitude, and this one is longitude and latitude. So longitude vertically divide about axis. The longitudes are parallel to axis of the earth, and latitudes are, this is noted as phi. Latitude is perpendicular to axis of the earth. So 24-degree Delhi location. This is not exact. I have taken just for example, Delhi is located at 24-degree latitude and 75-degree longitude. Actual values may differ. So here how we reach to Delhi. This is our reference point, because this is equator, greater circle. Equator here, and so 0, 0, 0. We have to move 24 degrees. So along the longitude, we have to 15 degree and 30 degree. Here you will find point. So you can draw line here up to 24 degree, like this, 24 degree, and move along this line up to 75 degree longitude. So up to 75 degree, this is 45, 50, and 75 degree. Here you will reach. So position of Delhi you will find here, Delhi. Suppose you want to reach Bombay. Next one is Bombay, Mumbai. Location is it is 18 degree and 70 degree. Maybe less so for Bombay. Bombay we reach here up to along the latitude we will move 18 degree. So 15 degree here you will find 15 degree, and between 15 degree, and here you will find, because earlier we have a, so this maybe this is line of 18 degree latitude up to move 70 degree. This is 60 and this one 70. So here you will find Mumbai. Suppose you want to reach Kolkata, and position of Kolkata is about 28 degree and 82 degree. These are arbitrarily taken value, not exactly, because I don't have data at this time. So for reaching Kolkata, just for example, for reaching Kolkata, it 28 degree, almost here 28 degree. I think okay, latitude will be lesser compared to Delhi. So this one is wrong here, absolutely wrong. Kolkata position will be less. So this one is at least we take a 15 degree or 15 degree, 15 degree and 82. So this one is a 15 degree line, 15 degree line, and up to 82. Here we move along 15 degree line and 82, 75. You will find here Kolkata position of. These are arbitrary value. And now taking, if you have exact data of longitude and latitude, we can make a map of the India by locating border line position of latitude. We draw joining these lines. We can simply draw the map of the country if we have known positions of the cities lying on the very close to the border. Suppose Chennai or Cochin, Thiruvananthapuram position is 18 degree, 10 degree, and 74 degree. So for Thiruvananthapuram, we will move along this direction. 10 degree means almost here, and 74 here. At this point, you will find Thiruvananthapuram. If you join these points, suppose one more point, Jammu, uh, Srinagar, Kashmir. Here we take 30 degree and 72 degree. These are arbitrary taken value. So we will reach here 30 degree along the, for the longitude we from 0 to 30 degree, and along longitude we will reach up to 72 degree. So here you will find a point, Srinagar. Now joining these points, you will see some image like India here. So this is a way you can draw position of India will be here. You will find in this region. So this is where this is the beauty of the knowing the longitude and latitude and reached at any point. This is a method by which Google Map work. By use of the geostationary satellite, we can reach any place if you know position of the longitude and latitude. Anywhere you can reach all over the world. So here, if we move from this circle, greater circle is known as Greenwich Mean Time. This is a GMT, Greenwich Mean Time. If we move here, degrees will be negative here. So time will reduce. If we reach 15 degree here, 1 hour will reduce. If we move here along this direction 15 degree, then 1 hour increase. That's why if you know position of the place by using Greenwich Mean Time line, and you can add for each 15 degree 1 hour, then you can exactly locate position and time of that place. This is also very, that's why this concept of longitude and latitude is very important from general knowledge point of view and from the solar energy point of view. So now next we are going to discuss solar angle geometry. Solar angle geometry. So what is solar angle geometry? Solar angle geometry. Solar angle geometry. And this geometry is very useful in finding out irradiance falling on the collector surface, whether it is a flat plate collector or concentrating collector, any kind of collector, because due to rotation of the earth, angle of incident of light radiation changes with the rotation of the earth. That's why this solar angular geometry is very, very important. So first now let us draw solar angle geometry. This is a horizontal surface. This is a horizontal surface. This is a reference surface, and this is a horizontal surface we have taken as a reference. This is a horizontal surface. North and south, north, east and west and south. This is a south. This is a horizontal surface anywhere. Though Earth is spherical, but this is a very big surface. That's why everywhere if you reach, you see that surface is horizontal, or small distance surface is always looks horizontal. And there is a plane. This is a plane. This is a plane located like this. And suppose it is a flat plate solar collector making an inclination angle beta with the horizontal surface. This line is drawn horizontally. So beta is angle of inclination of the flat vessel, angle of inclination of the collector with the horizontal surface. And now we draw a one normal. If it is normal from here, if it is normal to the earth surface, normal to the horizontal surface, and if one normal will be there, normal to the solar, normal to the plane. If it is normal to the plane, if it is normal to the plane, normal to the plane. There are two normal. One normal is this surface for this surface, and one normal if it is a point of observation O. And now position of the sun is here. Position of the sun is here. Let us remove this one. Position of the sun is here. Which is position of the sun. And radiation are coming like this, and it making an angle theta with the horizontal surface, and radiation is IBN, beam radiation IBN. So whenever we resolve this, because this is not perpendicular to the surface, this is not perpendicular to this surface, so we have to resolve IBN, normal beam radiation, along the normal to the plane. So value will be I dash BN equal to IBN cos theta. IBN cos theta. Other angle we have to define here. This is theta, and this one is a theta z, zenith angle. This is known as a zenith angle. Theta z is a zenith angle. And now projection of this beam along the horizontal surface will be like this. If you projection of this beam along the horizontal surface, so and an angle between this and this one, due south, angle between due south and line of projection on the horizontal surface of this beam is known as a solar azimuth angle, gamma f. This is very, very important. Gamma f is known as a solar azimuthal angle. This will be required. Other angles are angle of already beta I have defined, angle of declination. Del is angle of declination. angle of declination that is not showing in this figure. This is not shown on this figure, but this you know. It may be to the left of the, it may be along west to the south or east to the south. If it will be here, then gamma has become negative. If it is left to the south line from due south, if it is due south, north, east, west. If this projection is left to the due south line, then gamma s is positive. If it is right, then gamma will be taken negative. So these are angles. Theta is the angle of inclination of the beam. Radiation coming on the surface with the normal to the plane. This angle is always varying due to rotation of the earth, and for this angle we have to determine this angle by using our empirical relationship. For finding out this angle, we have to use empirical relation. That angle I will tell you. And this is the angle theta is varying, but this theta is very complex by taking conditions in which beta is zero for horizontal surface. Horizontal, because horizontal surface beta equal to 0, and for that condition cos theta become, because mostly practical values that we have to find out monthly, daily, average radiation and incident so under that condition we have to use beta is equal to due south, and for due south gamma has also become 0. If this projection line is along the south, then gamma has also become 0. If it will be become this shape surface become reverse to the due south, then gamma s become 180 degree. So gamma s is also varying, just like theta is varying. Theta varies for particular condition when incident radiation falling on the normal to the normal, means beta equals 0, and this surface lying along the horizontal surface, then on that case we determine cos theta. Cos theta equal to sin del sin phi plus cos del cos phi and cos omega. This is equation that is important for this equation is important for us because for finding out daily, monthly, daily average global radiation falling on the horizontal surface. For that case, beta becomes 0, and complex equation that is not required to remember, and no one can remember it. This is a very complex equation that I don't know it at present time. So that equation can be reduced in this form. If cos theta, this form when beta equal to 0. That equation is important for our consideration, and even we have to find out omega, means omega is our angle. Here omega is our angle from morning 6 a.m. to 12 p.m. 90 hours up to 90 degree, means 1 hour equal to 15 degree. You can divide from noon to evening 6, again 6 hour. So whole of the day can be divided into omega as hour angle. So for that case, and maximum hour angle we can get when theta equal to theta z equal to 90 degree, because maximum angle from 6 morning, at morning sun rays comes almost parallel to the earth, and at the noon sun rays just become perpendicular. So maximum angle when rays coming parallel to the earth, then zenith angle when rays coming parallel to the earth, then zenith angle become theta z become 90 degree, and we will get maximum angle. So putting that condition cos theta equal to cos theta z equal to cos 90 for getting maximum hour angle. So this will become 0 equal to sin del sin phi plus cos del cos phi into cos omega s. For that condition, we will get maximum hour angle. That's why omega equal to omega s. Under that condition, for getting maximum when sun rays are parallel to the surface at the morning, early morning, and at the noon sun become perpendicular. So from this to this point up to 6 a.m. to 12 p.m. 12 a, 6 a.m. to 12 a.m. up to noon, 12 noon. Maximum angle we get 90 degree, and 1 15 degree, 1 hour equal to 15 degree. So omega s we can calculate here by balancing this equation. Cos omega s equal to minus sine del sine phi upon cos del cos phi, that is equal to minus tan del tan phi, and omega s become omega s become cos inverse minus tan del tan phi. But this is not a total angle. This you will get in degree, because we have calculated this only for the morning to the noon, and from noon to the evening again we get 6 hours means 90 degrees. So we have to multiply omega s by 2 to get maximum hour, maximum sun sign hour. So how we can calculate maximum sun sign hours? How we can calculate maximum sun sign hours? Now erasing this one. Omega s we have just calculated omega s equal to minus, sorry, cos inverse minus tan phi and del into tan phi. And how to calculate time, maximum time, that is denoted by s maximum, average of the whole day. Maximum time s maximum equal to 2 times of the omega s into 180 upon pi into 15. 180 by pi, if omega is in the radian, here omega s we have taken in radian, so multiplied by 2 means, because morning to the noon and noon to the evening, we have to multiply by 2, because we have calculated earlier this equation only considering morning to the noon, and from noon to just we have to multiply. So this equal to 12 means, no, they is not required. I think for simplification, just we know if it is in degrees, there is no need of the multiplying by, already we consider it degree. If, because this you will find in degrees. So S maximum equal to 2 into omega S upon 15. Just you get hour. So 2 by 15 hour. Omega S, just this value you will get hour. So maximum possible sun sign hour is S maximum equal to 2 by 15. So 15 we have divided by 15, because we know that 15 degree equal to 1 hour, and 2 into omega s means morning to the noon and noon to the evening, and omega s we have calculated just from morning to the noon, and for noon to the evening we have to multiply it by 2. So you get maximum. This value omega s is in degrees, then no need of, if it was in radians, then you have to multiply by 180 by pi and divide by again by 15, then you can get hour angle. So this is a hours, 2 by 15 omega s. Here you must express that omega s is in degrees. Suppose it is not in degree, it is in radian. So then in that case, if omega s is given in radians, then how we can find our angle s maximum? Equal to 2 into omega s into 180 by pi divided by 15. So this become 12, 24 upon pi into omega s. Then this case, this become 24 by pi omega s. Here you have to express omega s in radians. Then you can use this equation. If omega is given in degrees, then use this equation. If omega is given in radians, then use this equation. So thank you very much for this discussion. I think this will help you, and it's very important. And one thing still remaining, let us discuss also how we define angle of declination. So we will discuss it in next lecture. Just going to discuss it. So thank you very much up to this point, because the lecture become lengthy and become boring. That's why I'm stopping here. Please like and share and subscribe, and also comment so that I can make any lecture for your choice. Any thing that you bring forward to me for discussion related to mechanical engineering, I will make video lecture for you. Thank you very much.